So we're going to start out by looking at section 7.2. Okay, as I said, today and tomorrow. 7.2 is on inverse trig. Okay, so for anything that we do in math, there's always a way to undo it somehow. Like if you square something, the inverse of that is square root. If you add, the inverse of that is subtract. Okay, there's always an operation you can use to cancel. Right? And that's what we're going to look at with inverse trig. All right, so basically, in general, if you want to think of what a inverse function looks like, okay, visually, it's a mirror image. Okay, what is it a mirror image of? Flipping something over the line y equals x. All right, so two functions we've looked at in the past that are inverses of each other are exponentials, which look like that, and logarithms, okay, which kind of look like that. Okay, they kind of go up and they level off. Well, if I drew in the line y equals x, okay, right there, and flipped everything over that line, that's how you can think of these functions. They're inverses because they're mirror images over that dotted line. Okay, any questions on that? Yeah, it might be kind of hard to see, but they are mirror images. Like if you took this point, okay, and measured that distance there, it should be the same distance, just mirrored on the other side. Okay, same thing for all. I didn't draw it perfect, but all right. So in order for a function to have an inverse, it has to pass the horizontal line test. Okay, so the horizontal line test, it's kind of like the vertical line test. Basically, it says you have to be able to draw a horizontal line and it only hits your function once. If it does, then the inverse is a function. Right? So if we look back at exponentials, okay, no matter where I put a horizontal line, okay, it's only going to hit the curve once, okay, which means it does have an inverse, and the inverse is a function. Okay. If I had a graph like that, a parabola, and I drew a horizontal line, how many times does that hit it? Twice. So parabolas do not have inverses that are functions. Okay. If we just look at half a parabola, then we could do it. Okay, so for a function to have an inverse, that is also a function. That's important. So for a function to have an inverse that's also a function, the original has to pass the horizontal line test. All right, so let's think about the graph of sine. If I draw a horizontal line anywhere that I want, is it possible it could hit the graph more than once? Yes. In fact, any horizontal line, if it hits the graph at all, is going to hit it how many times? Infinitely many. If it doesn't hit it at all, then that's separate. But if you put any horizontal line, if it hits it once, it hits it infinitely many times. So what that means is that sine does not have an inverse that's a function, unless we kind of narrow down where we're going to look. Okay, let's, what we're going to do is pretend like this is our window, okay, on our calculator. And we're going to just look at a certain section and see if that section has an inverse. Okay, not the whole function, just a section. So let's try looking at that section. Okay, does that section pass the horizontal line test? No, it still is hitting it twice. So what we're going to do is I'm going to kind of look at it right about there. Okay. If I were to draw a horizontal line, actually I can just take this one. Maybe. No, can't click it. But if I were to move that line up and down, would it ever hit the curve more than once now? No. So what we're going to do is we're going to focus on that section, and when we talk about inverses, we're going to limit kind of where we look. Okay, so our solution to inverse for sine not having an inverse is to limit the domain of the original from negative pi over 2 to pi over 2. Okay, that's what that window is. Negative 90 to positive 90. Okay, it should actually be right where those little tick marks are. My window's a little bigger, but. Right, and first thing we're going to look at is, if we do that, what is going to be the domain and range of our inverse? Well, if you know the domain and range of the original, then you automatically know the domain and range of the inverse. Okay. I said that an inverse is a mirror image over what line? Y equals x. So basically, all that happens when you mirror image it is y becomes x and x becomes y. So if you know the domain and range of the original, flip them, and that's the domain and range of the inverse. Right, so let's go back up look at our original. Oops. Right. What's, just move this away. What's the highest and the lowest that sine goes? 1 and negative 1. And is that my range or my domain? In the original, that's the range. In the inverse, that becomes the domain. Okay? So in the original, the range is negative 1 to 1. In the inverse, that becomes the domain. All right. And now, for the original, we restricted our domain to be between what two numbers? All right, so in the original, the domain was negative pi over 2 to pi over 2. What do you think that's going to become in the inverse? That becomes the range. If we didn't do this restriction, what would happen is when we drew the inverse, it would not pass the horizontal line test, the vertical line test. The inverse would not be a function. All right, so let's sketch that on the calculator and see what it looks like. Okay, one thing we know is that it has a definite starting point and an ending point. It does not go on forever in either direction. All right, so if you're in radians, that's about negative 1.57 to 1.57. So let's go negative 2 to 2. Okay, that should be enough to see everything. And for my domain, let's also go negative 2 to 2, just so it's not right on the edge of the screen. Great, and now type in the function. Inverse sine of x. Okay, again, that's my window. It's just negative 2 to 2 on everything. Get graph. And that is my inverse. Okay, if it kept going, what would happen is it would kind of cut back on itself, and then it would fail the vertical line test. That's why we had to do the restrictions we did, and that's why the calculator graphs it exactly the same way we restricted it. Okay, you could also get the same picture in degrees. Okay, what I would do there, instead of negative pi over 2 to pi over 2, I'd go like maybe negative 100 to 100. Okay, that way it wouldn't be right on the edge of the screen. Okay, any questions on what inverse sine looks like? All right, let's take a look at cosine, see if we can do the same thing. Let's look just at the original. Okay, I'm going to go zoom 7. Does cosine pass the horizontal line test? No, not the entire function. So again, we're going to have to narrow down where we look so that maybe we focus on just part of it. If we do negative 90 to 90, that'd be my left edge and my right edge. Would that pass the horizontal line test? No. So negative 90 to 90 doesn't work this time. but 0 to 180 does. Right, so for inverse cosine, that's 0 to pi or 0 to 180, that's going to be important. Okay, let's see. Somebody remind me, what's my range for regular cosine? My range for regular cosine is -1 to 1, so that's going to become the domain. And Brian, earlier when I put up the graph of cosine, I said we're going to limit the domain to be between what two numbers to make this have an inverse?
You said between 0 and 180, which would be 0 and pi.
Right. So in cosine, we restricted the domain from 0 to pi. So that's going to restrict in the inverse the range from 0 to pi. Right. We can take a look at inverse cosine. Okay, so just second, then your trig function. Have I showed you guys before how to do the inverse? Second, and then sine, cosine, or tangent? You see, have I showed you that? How do you type in inverse trig functions?
Yeah.
Okay, I'm just making sure. Some classes, I teach the same thing in 5 different classes. Sometimes I can't remember which one I taught that. Let's see. Okay, domain. I'm going to go -2 to 2. And what about my range? What would be a good value for range? Oh, Jacob, what do you think?
Like 0 to 3.5.
Yeah, I'm even, you know what I'm going to do, just so it's not on the edge of the screen, I'm going to go -1. And 3.5 is perfect. Anything bigger than 3.14. And that's your graph of inverse cosine. Okay, inverse tangent. So inverse tangent, that one looks a little different. Okay. If we graph the original, that definitely does not pass the horizontal line test. But what could I focus on here? What could I kind of narrow my window down so it would? Yeah?
You could do it to -pi/2 to pi/2.
Yeah, if we go -pi/2 to pi/2, we're just going to focus on that center curve. We're going to ignore everything else, and then we'll have an inverse. What else do we have in this function that we didn't have in sine and cosine?
Asymptotes.
What kind of asymptotes?
Horizontal. No, vertical.
Vertical asymptotes. Okay, in the original tangent, you have vertical. What do you think is going to happen to those vertical asymptotes in the inverse?
No horizontal.
They're going to become horizontal. Okay. Right, so let's see. To find the domain of the inverse, look at the range of the original. How high and low does that center curve go?
Negative infinity to infinity.
So that's going to become my domain. And the domain of the original, okay, Autumn just said -pi/2 to pi/2. And those are asymptotes. So big difference here, parentheses on the range, not brackets. Okay, and now we have horizontal asymptotes at -90, or -pi/2, and +pi/2. Okay, let's graph that. All right, I think zoom 7 is going to be fine for this, so let's just do that. Okay, so there's your inverse tangent. Yep. Okay, any questions on domain and range of inverse tangent? Okay, for today, we're not going to look at inverse secant, inverse cosecant, inverse cotangent. We could, but these are the three we're going to focus on. All right, so next we're going to look at six different formulas, 2 for sine, 2 for cosine, 2 for tangent. Okay. Basically, what these formulas are showing you is when inverse sine and regular sine cancel each other out. All right? So if I had a problem like inverse sine of, I'm going to do this in degrees just to make it simple. That's negative 90 to 90. So pick a number between 50. Okay, and I asked you what that equals. Well, as long as this number is between negative 90 and 90, these cancel out. And the answer is whatever is right there. Okay, but that trick of inverse sine and regular sine canceling only works if you're between negative pi over 2 and pi over 2. Okay, let me show you another one. Okay, so you can try it on your calculator. Second inverse sine of the sine of 50. Make sure you're in the right mode. Okay, so they cancel out, and I get back what I started with. That's going to work any angle between negative 90 and positive 90. Okay, if I try an angle above 90, okay, watch what happens. I don't get back the same thing. All right? So inverse sine and regular sine cancel out as long as you're between negative pi over 2 and pi over 2 in radians, or negative 90 and 90 in degrees. All right, now if you switch it, okay, put the inverse on the inside, sine and inverse sine will cancel out as long as x is between negative 1 and 1. Okay, so 1b is just take 1a and flip the two functions. Okay. So let's try sine of inverse sine of 0.6. Okay. When I hit enter, what should I get? 0.6. Okay. This will work for any number between negative 1 and 1. Now, let me try a number that's not between negative 1 and 1. Okay, let's try 1.36. Am I going to get 1.36 back? No. In fact, this time I don't even get a different number back. I get an error. Okay, and that's because you can't evaluate this inside trig function. You can't do inverse sine of 1.36. Okay, that's like drawing a picture of sine. That's at 1, putting a line at 1.36 and saying where do they cross. They don't. Okay? If you can't evaluate the inside function, it's undefined, then you can't do it. Okay? So any questions on 1a or 1b? All right, let's look at 2a. Inverse cosine of x. Okay. Formula 2a is going to have to do with the restriction we had earlier. What did we restrict the domain of cosine to? Original cosine. Yep.
0 to pi.
0 to pi. Okay, so as long as you pick an angle here between 0 and pi, or 0 and 180 if you're in degrees. Inverse cosine, regular cosine will cancel out. You can try that on your calculator. Okay, I'm not going to do that one. Okay, and now for formula 2b, cosine and inverse cosine cancel. But now in your head, think the highest and lowest that regular cosine goes.
Negative 1, 1.
Negative 1 to 1. Or the other way you could think of it, instead of thinking how high and low cosine goes, think of how far left and right inverse cosine goes. The domain is negative 1 to 1. Okay, and the last two formulas are for tangent and inverse tangent. Okay, again, I'm going to think of the restriction on the domain of tangent. Okay, what did we restrict tangent to?
Negative pi over 2, pi over 2.
And what's the difference between that negative pi over 2 over 2, pi over 2, and negative pi over 2? Then sine. What small difference?
It's not less than or equal to, it's less than.
It's just less than. Okay, there's vertical asymptotes at negative pi over 2 and pi over 2. And now for 3b, again, if I want to think of the restriction, I look at the inside function, think of the domain of inverse tangent. How far left and right does inverse tangent go? Forever. Negative infinity to infinity. Okay, so if you ever get stuck and you don't remember the restriction, look at the inside function, think of its domain. And that's what you go off of. Okay? So a question you might see on a test. It could be a true or false. Let's say sine of inverse sine of 0.6 equals 0.6. Okay, would that be true or false? True. Okay, look at your formula where sine is on the outside, inverse is on the inside. That's 1b. I had 0.6. That fits within the restriction of negative 1 to 1. Right, so this is true. Any question on that? Okay, another way I could word this, almost the same thing. I could say simplify. Don't write true. Okay. True doesn't work here. What would the answer be here? 0.6. So if it says simplify, you need to write a number. Okay, if it says true or false, then you can write true or false. Right, so those are the kinds of questions you could see. Probably just one or two on the test with this stuff. Okay, so any questions on the formulas? Okay. So with any of the functions I just put on the board, inverse sine, inverse cosine, or inverse tangent, we can transform them just like every other function we've studied all year. Every letter does exactly the same thing, all the same things you need to be careful with. So just as maybe a quick reminder, what would A do?
Left or right?
Yep, that's my horizontal shift. That's my horizontal stretch. Be careful with A and B. They do the opposite of what you would expect. All right, so if you see plus A, that's going to shift it to the left. If you see minus A, it shifts it right. If you see a big number for B, it causes it to compress. All right, so if B was, say, 3, you could say this is a vertical shrink by a factor of 3. If you wanted, you could also say stretch by 1/3. Okay, stretch by third, shrink by 3. It's the same thing. I don't care which way you say it.
Vertical stretch.
That's my vertical stretch. And D is my vertical shift. All right, so we'll come back to this at some point, and I'll give you an example with all numbers, and you'll just list all the transformations for me. What we're not going to be doing is sketching by hand. Okay, you do not have to sketch these by hand. All right, but if we do a transformation, we could affect the domain. Okay, horizontal stretching and shifting affects the domain. And then vertical stretching or vertical shifting affects the range. All right, so easy way to find the new domain is to make a compound inequality. Take your argument, which is that, bx plus a, put that in the middle, and then put the original domain, and if you need to go back and look it up, we can, on the left and on the right. I usually put in this order, smaller, like this. Let's put smaller, larger, argument, and then I can fill in my less than or equal tos or less thans. You always want to have them point towards the smaller. So if you want to switch smaller and larger, then you have to flip your signs as well. If we were doing tangent, we might want to be careful. It might not be equal to. Okay, it might be just less thans. Okay, but that's generally the order I'll set it up in. And then lastly, to find your range, all we have to do is take into account our vertical stretches and our shifts. So let's say, just to use easy numbers, we had a range from 0 to 2, and we stretched it by a factor of 3. Well, if you stretch it by a factor of 3, that becomes 0 to 6. That would be your new range. And then if you shifted everything up 1, we could go from 1 to 7. Okay? But always do your stretching, shrinking first, then do your shift after. You can't switch that order. Okay. So C, then D. Okay, so any question on the basic idea of how we're going to find our new domain and new range? Okay. And some problems, maybe only one of the two is changing. Maybe the domain stays the same and the range changes, or vice versa. They don't both have to change. All right, so let's start with that 2. Hey, Bill, what's that 2 going to affect? Is that going to affect the domain or the range?
The domain.
That's going to affect the domain. Okay, so the range, whatever it is originally, just copy that down. Okay, so what is my range for inverse sine? Yep.
Negative 1 to 1.
Be careful. Okay, range, let's just go back and look at it. Okay, range for inverse sine, that was the domain. So that's,
Yes.
yeah, that's
I
important.
mixed up switching.
we're gonna need that in a second.
Around to start.
Okay, so negative pi over 2 to pi over 2. And remember, for sine and cosine, use brackets on the range. For tangent, use parentheses. All right, now my domain. Okay, Brian just told us that. The original domain is negative 1 to 1. Put the smaller number on the left, bigger number on the right, argument in the middle. And this time it is negative 1 to 1 with brackets, so we do include it's equal to. And now solve for x, and we'll have our new domain. John, how do I get x by itself here?
Divide by 2.
Yeah, just make sure we do it everywhere. Okay, so what is my new domain now from what to what? Yep,
Negative 1/2 to 1/2.
negative 1/2 to 1/2. Which makes sense, because remember, big numbers compress everything. Okay, so this has been compressed by a factor of 2. Okay, it's been shrunk down, stretched by 1/2. All right, let's try this one. Okay, Sean Paul, what's that 1/3 going to affect? Domain or range?
Domain.
Yep, domain's going to change. So what I would do right away, just write down your range. Okay, we already have it from the last problem. Negative pi over 2 to pi over 2. Okay, anyone think they can tell me what the new domain is going to be? Yep, right?
Negative 3.
Yeah, it's going to be negative 3 to 3. If you're not sure, put the argument in the middle. Put the original domain on the left and right. Fill in your inequalities. And this time you have to triple everything. So we get negative 3 to 3. Okay, questions on that one? All right. I think I do have one that's not inverse sine. Yeah, we'll do in a second. Hey, Devin, what's different about this one?
There's a horizontal stretch or shift. What?
No, that one's not going to be horizontal.
Vertical?
Vertical.
Yeah.
Okay, so in this case, it's like that plus d on the end. So if we're going to shift it up and down, what doesn't change here? Domain. What's my domain for inverse sine? Negative 1 to 1. Now for my range, okay, let's just write down what it is originally. Negative pi over 2 to pi over 2. And what are we doing with that plus 2? It's going to cause everything to do what? Shift up 2. Okay, if these were nicer numbers, I would actually do this out. But you could just write this. Negative pi over 2 is shifted up 2. And pi over 2 shifted up 2. Only time I think a decimal is handy is if you're going to set your window. But you could actually type this in. Just put this in parentheses when you type it in. And the calculator will change it to a decimal for you. Okay, questions on domain and range there? All right, try that one on your own. Okay, take a second, see if you can figure out what's changing. And what stays the same? All right, so first of all, what is changing here? Just the range. Okay. So my domain is going to stay the same. What's the domain for inverse cosine?
Negative 1 to 1.
Yep. If you get stuck, what's the domain for the inverse? Think, well, what's the range for the original? How high and low does it go? Okay, and now the range of the inverse has to do with that restriction we set up on the domain of the original. What's my original domain for inverse cosine? It's 0 to pi. So now this is going to be 0 to 5 pi. That's my range. Okay. Questions? Questions on that? Okay, and the last one has to do with inverse tangent. And what's different about the domain of inverse tangent than any other inverse trig function? Okay, you are going to use parentheses, that's true. And what's going to be in those parentheses? Yeah.
No, I was going to say that. I was going to say, isn't it like if you do inverse tangent, isn't your domain always negative infinity to infinity?
Right, the domain for inverse tangent never changes, no matter what you do. Okay? So if the domain is negative infinity to infinity and you shift that left or right, it's the same. If you stretch it, it's still negative infinity to infinity. Okay, so anytime you see a problem with inverse tangent and they ask you for the domain, just write that as the answer all the time. And now what number do I have left that I still have to deal with? The 3. Yeah, my vertical stretch. Okay. What's my range? Where I could also say, what are my horizontal asymptotes for inverse tangent? Right?
Negative pi over 2 and pi over 2.
Negative pi over 2 to pi over 2, and we're going to triple them. So write negative, 3 pi over 2 to 3 pi over 2. Okay, so with this one, I could ask you also for the horizontal asymptotes. You don't have to worry about horizontal asymptotes on any other function. Okay, so any questions on those? All right, so this one is asking you to do something we've done before, just identify the transformations. And how many transformations do you think are happening here? Yeah, there are 4. And I would just be a little bit careful with the way they wrote this problem. There might even be something you want to do first. Just to make, this is not how I wrote the example. Okay? Especially this argument part. Okay, what might we want to do first here? Yeah?
Oh, you want to distribute the 1/4 to the x and to the plus a.
Yeah, then you can figure out what A and B are and see it. So Autumn, what would that give me?
That give you 1/4 x plus 2.
Plus 2. All right, so let's look at it that way. Now we can see A, B, C, and D. All right, so what's the first thing that's really happening here? Yep, horizontal shift.
Left 2 units.
We're going to go left 2 units. So horizontal shift left 2 units. Okay, second thing, and I'm going to ask you to write this one both ways, because you don't know which way I'm going to write it on the test. Okay, what's one way you could say the second thing? Yep, you could say vertical stretch. Horizontal stretch by factor of 4, and that's I think that's how I would word it. The other way is a little weird. It's a horizontal shrink by a factor of 1/4. Okay, so you're either stretching it by a factor of 4 or shrinking it by a factor of 1/4. I like the first way. I think that sounds clearer to me. Stretch it by 4. That's easier. The second way would almost be like if you wanted to shift up, you said shift down -2. Well, technically, if you shift down negative, it is up, but that's confusing. Okay, so I like that one better. Yeah, it's like a double negative. You have a shrink, and then you have something less than 1, so it really stretches. Third thing. Yep.
Vertical stretch by a factor of 3.
Vertical stretch by a factor of 3. And what's my last transformation?
Shift down 5.
Yep, shift down 5. You don't have to really write vertical shift. If you write down, down is vertical, so that's fine. Now, what would happen if 1/4 was a negative? We've talked about it, but we didn't do it today.
Flip in the x-axis.
So if 1/4 is negative, that's your horizontal. It would flip it horizontally. So that would flip it over the y-axis. If the 3 is negative, that's going to flip it vertically. That flips it over the x. Okay. So any questions on the reflections? So other than stretching and compressing, they can cause flips over x or y. Right, and we'll just practice evaluating a few trig functions. Okay, so just try those on your own. Okay, let's do the answers in degrees and radians.
Wait, so the numbers you've given us in radians?
What's that?
The numbers that you gave us are in radians, right?
This is not an angle. This is just a number. This number has no units to it. Okay, anything you plug into inverse trig is just a pure number. If you plug something into a problem like this is an angle. The answer is a number. With inverse sine, it's just the opposite. Let's call this number. Okay, and this is an angle. Okay, does that make sense?
Yes.
Regular sine, your angle is the argument. Inverse sine, your angle is the answer. So that's why you're going to write your answers in degrees and radians. All right, so I think the easiest way to do it is, why don't we do everything in degrees first, and then we can switch to radians. All right, so I'm in degrees already, so you just press second, inverse sine, 0.5, and what do we get when we hit enter? 30 degrees. Okay. Anytime that I'm going to show you something in a second, but anytime your argument is a number like 1/2, square root 2 over 2, square root 3, square root 3 over 3, any of those special right triangle numbers that we've seen before, you're going to get a nice answer. So you're looking for 1/2, square root 2, square root 3s, things like that. -7/10, it's not going to be a nice answer. Okay, what'd you get? Negative? Yep, so let's go 0.43, negative 44.43. Okay, and it's very important you put that degree symbol on it. Okay, if well, when we do it in radians, I'll show you something. Okay, what's inverse sine of 1.2? Yeah, that's undefined. Remember what we said. Think of the inverse trig function. This is not, 1.2 is beyond 1. We've got to be between -1 and 1. Okay. All right, so now when we write it in radians, okay, did anybody write decimals? Didn't say not to. Did I do that? Yeah, decimals. Okay. Generally, when you see a problem and the angle comes out nice in degrees, we can write it nice in radians. Here's how you could confuse yourself. Okay, go to radians, type inverse sine of 0.5. Like, oh, 0.52. Okay. Well, because it had a nice answer, I think this is more confusing to look at. So what I generally do is I try it in degrees first. If I get a nice answer, then I just convert that in my head to radians. Okay. What is 30 degrees in radians? Pi over 6. Now, if you check, take pi, divide by 6, it will be that 0.523 number. But if you look at 0.52, you probably won't recognize it as pi over 6. So the hint, do it in degrees and then convert. Okay, for the second one, that's not a nice answer, so I wouldn't expect a nice answer for radians either. Okay, decimals.
0.7.
What do we get?
0.775.
0.775?
Negative 0.7.
Negative. All right, now for part B, okay, if that was a question on a test, okay, so let's just say I had choices listed, let's say choice 1, 44.43, choice 2, negative 0.78, choice, I'm just going to put 3 choices, negative 0.7. Okay, which choice is correct there? 2. Choice 1 is wrong. Why is choice 1 wrong? Oh, let me even add a negative. Yeah.
You don't have the degree.
I don't have the degree symbol. Okay, if I do this, which choice is correct now?
1.
Now it's 1. Right, so be very careful on the test if it's a matching question. Look at my answers and see if they're in degrees or radians. Right? If they're in degrees, they have the circle. Otherwise, they're radians. All right, and choice C, in radians, it's also undefined. All right, let's look at one more. Let's do inverse tangent of root 3 over 3. Now, I would do it in degrees first. If you do it in radians, you're going to get a messy number. But if you do it in degrees, you're going to recognize it as a nice answer, and then we can change it. Anybody get an answer for inverse tangent of root 3 over 3, Derek?
I got 30 degrees.
It is 30 degrees. Okay, so when you start seeing numbers with square root of 3's, divide by 3, start thinking this is probably a nice answer. Okay, and now in radians, pi over 6. Okay, not 0.52 or whatever. Let's do inverse cosine root 2 over 2. Okay, anyone think they got an answer for that one? Yeah?
45.
It's 45 degrees. Again, do it in radians first, and you're going to see a messy decimal. Do it in degrees, you get a nice answer. And then what is pi? What is this in terms of pi?
Pi over 4.
Pi over 4. Okay, any question on that? All right. Last thing I want to do is just think about this last one visually, okay, rather than typing it in using inverse trig. I want to think about it as a graph. So let's start with this. Right, let's just say we had that. Inverse cosine of something equals something else. What could I do to cancel out inverse cosine? I could take the cosine of each side. Okay. And basically it's like saying that. I'm asking you where the cosine of y equals x. Okay? Same thing. All right, so let's just say that equals a number. And if I'm going to graph, you know what, it does make more sense to use x in this case, but you could really use any letter you want. What's another way to reword this question? Instead of inverse cosine of root 2 over 2. Think about getting root 2 over 2 by itself. Yep.
You could do cosine of x equals square root over 2.
Yeah. Another way to think about that question is just like that. And now, how could I use that and my graphing calculator to get the answer?
Inverse cosine.
Yep.
By doing cosine of x and see where square root of 2 over 2 will cross it.
Yeah, just see where they cross. Okay. See where the cosine of x and the horizontal line root 2 over 2 cross each other. Okay, let's do zoom 7. Okay, I'm in radians. I'm going to change to degrees. And remember, we get infinitely many answers. But think about inverse cosine. Okay? That's going to give us an answer between certain numbers. Okay? We said earlier the domain of inverse cosine is between, just go back and look at it. Okay, -1 to 1, and the range is 0 to pi. So our root 2 over 2, okay, that's about 0.7. Okay, that fits in the domain. Our answer we're going to get is going to be between 0 and 180 degrees. Okay. So what we really want to do is just look between 0 and 180, and I guarantee you won't have a horizontal line hitting it more than once. This is the very same thing I did at the beginning of the class. It's the first thing I showed you. Right? And let's see where they cross. Crosses at 45 degrees, which hopefully that's what we got. 45 degrees. All right, so all these problems we're doing, you can think of them purely as algebraic equations you're going to solve, or you could think of it as a graph and you're calculating an intercept. Okay, if you ever forget, it's another way to do it. Okay, any questions on that? All right. So I'm going to give you a little bit of time to start the homework. Okay, it's on 394. I'd like you to try 1 to 9 all. Actually, it's all on each part. 1 to 9, 13 to 20, 20 to 24, and 27 to 33.